Chemistry, chapter 6 topics, whatever you want to call it. This quiz, nitrogen. Go through the notes. Where is it? They go through these notes. Please read them. Please read them. Yani, wallah, it's like 3 pages. Skip the questions. Just read the questions. I should read read the like actual stuff. It won't take you more than 10 minutes. Oh, she'll probably bring from them. Okay. What are the conditions for the Haber process? Memorize them. For some reason, in the exam, she put 200,000 kPa. People got it wrong. They shoot 200,000, 20,000, 200, 180. Hold up. Yeah, no. In the exam, she put for you. She didn't put ATM. She just put the kilopascal. People got it wrong. If you don't know, 1 ATM is 10 to the power 5 kPa or 100,000. Shoe kPa as the PA only Pascal. Okay, 1 ATM is 100,000 Pascal. Okay, so obviously 200 ATM is like, I don't know, 200 times 10 to the power 5 Pascal, which is 2 times 10 to the power 7 Pascal. If they made it in kilo, when you make it kilo, you divide by 10 to the power 3, divide by 1,000, so it's gonna be kPa like this. Okay, 2 times 10 to the power 4 is 20,000. ماشي. Okay, the temperature 450 for both the Haber and the contact process. It's 450. Okay, for the catalyst is iron. You know that the catalyst increases the rate, but it has no effect on the yield. These are easy questions. Okay, this is more chapter 2 related. I don't know why we put it in this chapter, but the presence of ammonium ions can be tested in many ways. How do you test for NH4? Remember, let's forget about chapter 6 topics. Let's think more chapter 2 now. And I'm recording this after I recorded chapter 2. In chapter 2, نحن اتفقنا to test for NH4. You add NaOH, and it's gonna form ammonia and water. Okay, so which of the following chemicals can be used to test for ammonium? It's now we put NaOH, but in general, it doesn't have to be NaOH. It can be anything OH. Okay, any hydroxide, because the whole point is that the NH4 reacts with the OH group. Okay, when a solution of ammonium is treated with warm solution of NaOH, a gas is released. Now we know that the gas with the pungent smell is released. We know it's ammonia, the gas, right? What is the gas? NH3. Okay, then they said write the equation. It's basically what I just wrote here. That's it. Obviously, put the state symbols. These are aqueous, obviously, because ions. And we said NH3 is the gas, water is a liquid. Okay, just write the equations. 3. Okay, nitrogen is extracted industrially by liquefying air at -200. Okay, this was a multiple choice question, by the way, and I got it wrong, I remember, because I didn't know it was -200. Okay, which of the following is extracted? We know it's water and carbon dioxide. It's extracted as أول شيء, like they liquefy it, air at -200. At -200 degrees Celsius, water and CO2 become solid, so they get rid of it. Okay, what's left after that will be nitrogen and oxygen after they remove these. Okay, after removing the solidified gases, what separation technique? It's fractional distillation, not simple distillation, fractional. Okay, careful. And what gas is extracted first? أكيد nitrogen. Okay, very easy. Nitrogen is the one also that we're trying to use. أكيد is going to be the answer. Okay, we want to find the unknown salt X. Salt X is soluble in water. Okay, a solution of X forms a white precipitate when you add AgNO3. We know when you add AgNO3 you get a white precipitate. This is from chapter 2. That means it's Cl-, right? Okay, then they said a gas of pungent smell is formed when you added NaOH. Okay, what pungent smell, by the way, whenever you see pungent smell, you have to know it's ammonia. We know that ammonia is formed when you mixed something with NaOH. And what is that thing? Akid, it's NH4, right? So NH4 and Cl. What's the cation? The positive ion. It's akid, NH4 plus. What's the anion? Cl-. What's the chemical formula? Just add them together, NH4Cl, and this is called ammonium chloride, right? Okay, 5. Select from the following the correct properties of ammonia. This was a question in the CA. Pungent smell, it's basic and it turns moist red litmus paper blue. كمان it's less dense than water. وكمان it's highly soluble. شو water يا الله، قصدي air مش water. Less dense than air و highly soluble. Okay, highly soluble in water. In the exam, what did they do? They didn't say highly soluble, they said partially soluble in water, so it was wrong. Okay, this is correct. But in the exam they said partially. Partially أكيد غلط. Okay, then they said the fertilizer ammonium sulfate, okay, is prepared by mixing an aqueous solution of NH3 with an aqueous solution of H2SO4. Then they said give the chemical equation. Very, very straightforward. We're mixing aqueous NH3. So you just write NH3 aqueous plus aqueous H2SO4. You just write H2SO4 aqueous. And we get what? They gave you the product. Just copy it. And obviously, the fertilizer will probably... Is it aqueous? Yeah, if you have aqueous, it should be aqueous as well, I think. Fertilizer... I think, wait. Yeah, it should be aqueous as well. The fertilizer should be aqueous as well. Okay, let's just balance it. Let's say the 2 wasn't here. No, obviously it's an answer, but saying let's say it's not there. You have 2 nitrogen here, but here you only have 1, so you just multiply by 2. خلاص, it's balanced. Okay, then they said, listen, part I whatever is a bit هيدا. Give the net ionic equation for the above reaction. صراحة I don't agree with this answer. I don't get why, but يعني I don't know. Look over here, NH4SO4. You're gonna ask, طب you had NH3, how did it become this? Okay, look, when you're dissolving NH3, okay, it's a base. When you dissolve it in water, you get NH4 plus OH minus. Okay, something like this. شو oh, is NH4. You get something like this. Okay, المهم. So the net ionic equation, since you're dissolving NH3 in water, so for it to become NH4, it just gained a H+. And I don't, I'm not convinced with this, but I guess just memorize it. If NH3 turns into NH4, it gains a hydrogen. Again, I'm not convinced. Question 6. Okay, here we have, this is the Haber process and how to produce ammonia. Okay, to increase the rate, careful, increase the rate. How would you increase it? Obviously, increase temperature, increase pressure. Here to increase yield. Increase yield, and they want to favor the forward. If to favor the forward, let's see. Temperature. If I wanted to go forward, let's see. The forward reaction in this case is exothermic. Okay. How do I make it go forward if I know the forward reaction is exo? That means I have to decrease the temperature, because if I decrease the temperature, the system will increase temperature. And to increase temperature, that means it's going to go exo. We know that the forward is exo, so that way it will go forward and thus increase the yield. So decrease in temperature. Just do the opposite. Look. If the forward is exo and you want to go forward, you do the opposite. So it counteracts it. What's the opposite of exo? Going like decreasing temperature. Okay. So decrease temperature. How about pressure? And again, I want to go forward. Remember, with pressure, it goes, if you like, it goes towards, if you wanted to go forward. Forward in this case, with pressure, you look at how many gaseous moles you have. On the left, we have 4, 1 and 3. On the right, we have 2. We want to go forward. We want to go towards the less gaseous moles. When does it go to less gaseous moles? When the system decreases the pressure, right? When the system decreases the pressure. So to go forward, the system is decreasing pressure, right? If the system is decreasing pressure, that means what did we do? Remember, the system always does opposite to what we do. What did we do? We increased the pressure. That's also for the first part. You could have solved like that as well. We could have said to go forward, the system is increasing the temperature. That's why it's exo, right? To go forward, the system increases the temperature. If you're going forward, since it's exothermic. So what is the system doing? The system always does opposite of what we do. So if the system is increasing temperature, that means that we decreased. Think of it like this. What if you add a catalyst? What happens? It only increases the rate. It never increases the yield. Remember, in equilibrium, catalysts don't have any. Okay, this here, I'm going to show it in the notes. Okay, so I'm going to explain the one in the notes. I'm going to explain the one there. They're pretty much the same thing, but like just arranged differently. Okay, if you're taking the IG, you need this. This is to produce ammonia. Ammonia is produced in this equation. Okay, it's equilibrium NH3 You have 662 over here. Okay, gas. Whatever here. I don't know. Is it aqueous? I think it's aqueous. Oh no, gas. Come on. Yeah, nitrogen gas, hydrogen gas. Okay. This is the reaction to form ammonia. You're gonna need it for this question. أول شيء, how does it work? They pump in after they separated the nitrogen and hydrogen. They pump it in. How do we get nitrogen? Nitrogen is got from the fractional distillation. Okay. Of liquefied air. I explained it earlier in the recording, right? Liquefied air. How do you get hydrogen? From methane. Okay, methane, or they don't really say, they don't ask this, but also from the electrolysis of water. But the most important one is methane, but still no electrolysis of water. Anyway, so we got it, and they start mixing and scrubbing it. It goes into compressor where it starts like pushing it onto each other, and it takes them down here to down. Now after the gases are compressed with each other, this is the reaction chamber. Okay, this is the reaction chamber. In the reaction chamber, obviously there's catalysts to speed it up. Okay, and they call it converter or reaction chamber. After the reaction chamber, the gases go down, and obviously, as you can see, not all of it is converted into NH3. Remember, it's an equilibrium reaction, right? So, okay, we're gonna have some NH3, and what they do is it goes into a cooler. Okay, you guys know when you cool something down, the one with the lower boiling point will condense and flow out. But these gases don't have a low boiling point, the N2 and H2, so they're gonna remain gases. And what are they gonna do? They're gonna continue flowing back up, and then they repeat the process. And this is gonna keep on happening until it runs out of N2 and H2. Do you get what I'm trying to say? What I'm trying to say is that you're gonna have leftover products, leftover reactants. Sorry. So what do? They said, oh, if we cool it down, only the NH3 will leave. These two will stay stuck in, and that way we can just send them back up again, so they go through the reaction again. Every time there's leftover reactants, this is how they call it recycling. Okay, they call it recycling. And this recycling process, it's written here. By recycling, the yield can be increased to about 98%. Okay. So we go now to our question, and it should make a bit more sense. Nitrogen gas is obtained here. Nitrogen is gotten from what? We said liquefied air, right? Hydrogen is gotten from what? Methane. Okay, what's the correct hydrogen to nitrogen volume? Remember, we said N2 plus 3H2 to produce 2NH3. What's the ratio for hydrogen to nitrogen? Hydrogen I have 3, nitrogen I have 1. Done. Choose the compartment where the catalyst is embedded. The catalyst, even though this looks different than the other picture we have here where is the catalyst embedded? In the converter, or other people call it the reaction chamber. Okay, so in the reactor. Because when do we need the catalyst? We need the catalyst when the reaction is happening, so we need it in the reactor. Okay, choose the compartment where the unreacted gases are directed. Okay, like the picture we had in the notes, we finish off with unreacted gases. What happens to these unreacted gases? They get sent out, and where do they go back? To the reactor. This is a very bad drawing. I don't like it, but anyway, we know it goes back up into the reactor, like over here. They send it back up. They send back up through the reactor, right? Okay. ماشي. So the unreacted gases, they go back to the reactor, obviously, because we want them to go react again. When petrol burns in a car engine, what do the catalytic converters do? They convert the pollutant gases. What are the pollutant gases in a car? Carbon monoxide and nitrogen monoxide. Okay, that's it. Thank you so much for watching, and good luck.